The last thing we need to learn about in this unit is dilution. So, if you've ever made a solution of sweet tea, solute sugar, solvent tea, if it was not sweet enough, how would you increase the concentration? Well, you would add more sugar. If it was too sweet, how would you decrease the concentration? Well, you would need to add more unsweetened tea or water in order to make it less concentrated. So dilution is the process of adding solvent to a solution to lower that concentration, where it's at a higher concentration and you're going to add solvent to make it lower. In our sweet tea example, our solvent was the tea, but in chemistry it could be a whole variety of things. The actual numbers of moles of solute never changes. We still have the same number of moles, we just have a different amount of liters, which causes the molarity to change, just like you learned about in our last video. Only the amount of solvent changes to reduce the molarity of the solution. Let's look at what I'm talking about. So we have solutions 1, 2, and 3 right here. You can see that each of them have 8 of those red particles in them, whatever you want to pretend they are. But they each have a different volume, where this one only has 1 liter, this one has 2 liters, and this one has 3 liters. So which solution is the most concentrated? Well, that would be solution 1, because it has the red particles the closest together, so it is the most concentrated. Which one is the most dilute? Well, that's going to be solution 3. Compared to the amount of liquid we have, there are very few particles floating around in there. So it's going to be a lot more dilute because it has 4 times the amount of water as solution 1. What happened to the volume as we dilute the solution? Well, we went from 1 to 2 to 4. So like I just said, our solution 1 has way less liquid than our solution 4. This one's actually has 4 times as much liquid. So what happens to the amount of solvent throughout the dilution? Well, the amount of solvent is increasing. So we added 1 liter here, we added 2 liters to get to here. So we are increasing the amount of solvent. What happens to the amount of solute throughout the dilution? Well, you can see that it's staying the same. We have 8 particles of solute, 8 particles of solute, and still have 8 particles of solute. It doesn't change. Only the volume of our solvent is changing. So what happens to the concentration of a solution throughout the dilution? It gets less and less concentrated. Where this one was our most concentrated, this one was in our middle, and then this one is the least concentrated. Now you can do calculations with dilutions. Don't freak out, it's a super easy calculation to do. So when you need to dilute a solution, you know 3 of the following 4 things. You know the molarity of what you started with, the new molarity of the solution you want to make, the volume of the solution you start with, and the volume of your new solution. So you need to know 3 of those 4 things. Whatever thing you don't know is the thing you are solving for. So we use the dilution equation M1V1 equals M2V2 to solve for that last variable, where M1, as we just saw, is our starting molarity, and V1 is our starting volume, and M2 is the molarity we want, and V2 is the volume that it's going to take to get us there. We know 3 of those 4 things, so you just solve for one of them. So it's just like basic algebra where you solve for one unknown variable. Volume in this can be in units of milliliters or liters. You just have to have the same on both sides. So if you're given both volumes in milliliters, great. Both volumes in liters, great. But if you're given one in milliliters and one in liters, you're going to have to convert one of them. But you can use either otherwise. So as far as our calculations are concerned, let's do a practice 1 together. You were told to calculate the molarity that results when 250 milliliters of water is added to 125 milliliters of 0.251 molar HCl. So first we're going to assign our variables to figure out what everything is. So V1 is our 125 milliliters. V2, because we are told is added, is our 125 originally, and we're told 250 milliliters is added. So we add that in to have 375 milliliters. Our M1 is our 0.25 moles, molarity, right there from our problem, which means our M2 is what we are solving for. So we're going to plug into our formula and solve for the unknown, which means that our formula is going to be M2 equals M1 V1 divided by V2. We wanted to get our unknown variable, our M2, on a side by itself, just basic algebra. Then we plug in our numbers, enter it into your calculator, and you should have gotten that M2 equals 0.0837 molarity. Not so bad, right? You've totally got this. So why don't you try some practice problems on your own? So suppose you wish to make a 0.879 liter of 0.250 aqueous silver nitrate by dilution a stock of 0.675 molar aqueous silver nitrate. What will the volume of the stock solution would you need to use? I also want you to calculate the new concentration when 50.0 milliliters of water is added to 735 milliliters of 1.25 molar sodium chloride, and how much water would you need to be added to 750 milliliters of 2.8 molar HCl solution to make a 1.0 molar solution. I want you to pause this video and come back when you're done. Just like our previous examples, if you don't show your work for how you solved these, you won't be able to use your notes on the note check. Pause your video and come back when you're done. All right, let's see how you did. Just a reminder, if you don't show your work for how you got these answers, you won't be able to use your notes on the note check. So for example number 2, you should have gotten 0.326 liters. For question number 3, you should have gotten 1.17 molar. Hint, you had to add the 50 milliliters to the 735 milliliters for your V2. If you only used 50 milliliters as your V2, you probably got a weird answer. Go back and try it again using this hint. And last but not least, your number 4 should have been 1,350 milliliters. You may have gotten 2,100 milliliters as your answer, but if you remember, you had to subtract the 750 milliliters from your calculator because it was asking you how much were you going to have to add. That V2 of 2,100 milliliters was our total, so we were only adding 1,350 milliliters. So an important thing with dilutions is to make sure you're reading the question carefully and answering the question asked. We're going to be doing some practice problems in class, so come ready.